All right, we're back and we're coding Blackjack. In our last video, we coded the card class, which has a rank and a suit. Suits are things like hearts, diamonds, clubs, spades, and our ranks are basically the other symbol that appears on the card, right? Our 2 through 10 are Jack, Queen, King, and Ace. Okay, we used integers here in order to represent these things. They get basically translated because these string arrays that are inside of the card itself kind of very easily help us translate. It's pretty easy to translate something like a 2 or a 10 because we're just going to the index and then turning it into whatever's there at that index. Where this approach is clever is when we get to something like these other things, like a jack, right? A jack basically appears at index 11. It is a jack kind of ranks after 10 in terms of ranks. Our ace at the very end, and basically I've left indices 0 and 1 kind of blank. You could fill these in, right? But you just got to keep track of all that stuff. Okay, we do a similar thing with our suits. Effectively, a 0 represents a heart, whereas a 3 is a spade. So this translation really happens down here in our 2 string, where we go inside of the arrays and pull out the corresponding thing in order to see it. For instance, in my driver, I'm making a 14-2. That is rank 14. 14 is an ace, and 2 is a club. However, the rank, it's important to note, is actually different from the value. When we're talking about value in terms of blackjack, we're talking about the blackjack value. In the case of your numeric cards, a simple 2 through 10, it is that is the value of the card. An ace can be a 1 or an 11. Here we're going to treat it as 11 because the only time that it's relevant as a 1 is when it's in the hand itself. So we're actually going to take care of that later on whenever we write the get value method for a hand. And basically, if it's not a numeric card, if it's not a face card, if it's not a numeric card, if it's not an ace, it's a face card. We're talking like our jack, queen, king. Those all have a value of 10. So the get value, slightly different from the rank, but this was our card class. We're going to pick it up there. And looking back at our wicked public interface, right, there's a lot going on here. We completed card. We're going to do deck. Deck is the next one we'll do, and then we may get into part of hand. Something I'd like you to kind of note here is that not only are we showing one class, we're actually showing the relationship between that. What do I mean? We have these lines drawn in between, and you see this 1 and this asterisk. What that means is one deck will have many cards. You can see something similar over here. One hand consists of many cards. One player can have many hands. More on that later. But let's get started with deck. I'm going to create a new Java class by right-clicking on my SRC, making a new Java class called deck. Now, you could just do an array list of cards when and where you need it. Putting it inside of the deck is actually going to make it a little bit easier to manage the deck. For instance, we're going to basically kind of create a deck and like shuffle it and then deal, which is basically pulling the top card off. And those methods that we're going to write is going to help manage the array list a little bit easier for us. So while the deck class is not necessary, you could just make an array list of cards where you need it. It's nice. So I'm going to create a private instance variable here. It is an array list of card. Okay. And we'll call that cards. I need to import array list. I kind of skip past that. We can hover over it, hit Alt-Enter, and IntelliJ. First option here is import the class, and there it is. So I'm declaring an array list instance variable called cards. This particular array list can hold card objects. That's what we made in our previous video. I'm going to make a constructor. And what we want to do is initialize the instance variables. I have an array list instance variable declared. Right now, it's pointing at null. I need it to actually point to a new, cards with an S, a new array list of card. Okay, so now the array list exists. It can hold card objects. Right now, there's nothing in it, and we need to fill it. And this is where our idea of using integers to represent these things is actually going to come in clutch. What do I mean? I need to basically make 2, 3, 4, all the way up to ace for each suit. Okay, so for each suit, I need to make each rank. Or vice versa, you can look at it, for each rank, I need to make each suit. So that is going to be nested for loops. I'm going to create some variables here, and to kind of help us keep on track, I'm going to create integer rank. Okay. Let's backtrack this for a second. I can use the IntelliJ syntax here. I'm going to type in for I to kind of plug in my for loop syntax. But instead of using I, I'm going to rename this bad boy rank. Right? Notice that it allows me to rename it, and it also renames all occurrences of I to what I want it to be. Think about this for a moment. What is our first rank? What is our first relevant rank? Effectively, the ranks that I care about, let's bump the driver over here. The ranks that I care about are these. Right? We're not using 0, 1. This is to kind of help us mentally keep track. You could kind of offset this, right? We could use these indices, and really like index 0 is a 2, but then you got to like remember that. This is how we tend to think about the ranks of cards, so I've laid it out that way. What this means, however, is I don't want to start rank at 0. I want to start it at 2. And we're basically going to go through these numbers, right? My last index being 14. So we're going to start rank at 2, and as long rank is less than 15, or what would kind of make more sense is saying less than or equal to 14. All right, 14 is a possibility. That's going to be the ace. So this is my loop for my rank. That's going to go through all the ranks. Inside of it, I'm going to nest a for loop. This particular one, I want to go through all of the suits. In the case of suits, I've got 4 of them. My first one is effectively 0. My last one is effectively 3. So we're going to start at 0. That sounds good, as long as it's less than or equal to 3. So that's it. These nested loops will go through each rank, each suit. Right? Basically, we will select the rank first, meaning a 2, and then we're going to go through each suit. So what this is going to do is make like the 2 of hearts, and then the 2 of diamonds, then the 2 of clubs, then the 2 of spades, and then it'll go to 3 and make the 3 of hearts, the 3 of diamonds, the 3 of clubs, the 3 of spades. If we were to invert these loops, right, if I was to move this bad boy up, we would basically go through each suit first, making all of the ranks. So my first suit being a heart, right? I would select effectively a heart and then do the 2 of hearts, the 3 of hearts, the 4 of hearts, the 5 of hearts. Ultimately, this doesn't matter unless you really, really want them in a particular order in the deck. But as you're going to see, we're ultimately going to shuffle the deck, so it doesn't matter. But with each iteration of the inner loop, I have my rank, I have my suit, I need to create a card. I'm going to add to the cards array list a new card that I'm making on the spot using our rank and our suit. Now this order does matter, right? The order that you write them in the constructor matters because the first number coming in is the rank, while the second number coming in is the suit. So we're going to create a new card right here on the spot and add it to our cards array list. Okay, why don't we see what that looks like so far? Now this isn't going to be shuffled, and if we look back at our public interface, I don't have a 2-string, but for testing purposes, I'd like to know what my deck looks like. So I'm going to Alt insert a 2-string real fast. It's going to ask me what instance variable. There's only one. I want to use that. Okay, so this should show me the contents of cards, right? Notice this cards variable right here. That's talking about the instance variable. There's some annotations here that are kind of just silly. So it's going to show me the cards array list. And each element in cards is a single card, which means we're going to be calling the card 2-string, which we wrote. So we should be able to see this. I'm in my driver. I want to test my deck. I'm going to create a deck object, and I'm going to print it off. I'm going to tell my program to run, and this should show me all of the cards. Again, you look, that is the hearts. Based on our order, we selected the suit first, and then the inner loop's going to go several times before moving on to the next suit. So we did all of the hearts and then all of the diamonds. If we were to invert this, we're still making all the cards. All 52 cards are being made. It's just going to do all of the 2s first and then all of the 3s first. This ultimately doesn't matter. What does matter is that you do rank suit in the correct order here whenever you're calling the constructor. But this doesn't matter because we're going to shuffle it. Okay. Now this process right here where I am kind of filling the deck, I am creating all 52 cards and putting them in the deck, I recommend extracting that out and putting it into some type of helper method. I'm going to call it fill or populate, something like that. Right? These 3 lines, 11 through 13, I'm going to cut those things. You can do that with Control X, and I'm going to put them here. The reason being is that as we deal cards out, eventually we're going to run out of cards in the deck. And our options include, like not technically getting rid of all of the cards, creating a new deck and abandoning the old one, or what is actually ultimately the easiest option is keeping the deck object that doesn't actually have cards in it, but putting all 52 cards back in. Okay, so I basically extracted it out, put it in this little private helper method so I can call it individually without having to do everything else, but it does allow me to call it here on the spot. Okay, so whenever we call the constructor, which we're doing here in the driver, we're going to go in here, we're going to create a new array list. We then call the fill method. The fill method is very specifically going to add card objects to the cards array list. Now, they're not shuffled at this point. If I were to run it, we're going to get the exact same result. So you see that it is working, it is the same result, but we need to shuffle. I, again, recommend a helper method. This particular one, I'm not actually going to end up using it anywhere other than right here. Right, as soon as we fill the deck, let's shuffle it. Now I need to write the shuffle, and you probably very recently wrote a shuffle dealing with arrays. It is so much easier with array list. Check this out. We're going to make an array list of card called temp. My logic here is I'm going to create, I have my deck, right? It's got cards in it. I'm going to create an empty array list over here. Really, I should say I have my array list. It's got cards in it. I'm going to create an empty array list over here. What we're going to do is random an index in our array list. We take whatever card is there, we put it into temp. Okay? And then after I put it there into temp, I need to remove it from my cards. Eventually, we keep repeating that process, and our array list of cards gets smaller and smaller and smaller until it runs out. So the way our loop is going to work is we'll say while cards.size is greater than 0. While I still have cards to transfer, let's keep going. Right? I want to random an index. Using math.random, in total, there are 52 cards. The problem with just using this static 52 number is that as I remove cards from one array list and put them in the other, it's going to potentially go out of bounds when I try to random an index because, again, I'm removing cards. Fortunately, array lists are super dynamic, right? So as I'm doing this, the size is going to get smaller and smaller and smaller. Initially, the size is 52. But that is going to automatically update as I remove cards. So this is super sweet, right? This will be so much harder with arrays. So we random an index based on how many cards do I have left. Notice that we can get 0 out of this, and that's fine. 0 is a valid index. So I've got the index of the card I want to actually transfer. Right? I want to add that to temp. So temp.add cards.get I. I'm going to go into my cards array list that has card objects in it. I'm going to find the element that I just random. I'm going to add that to temp. Technically, I basically have 2 copies. What I really have are 2 indices pointing at the same card object. So I need to get rid of it from cards. Right? It's in temp. That's sweet. I then need to say cards.remove whatever's at I. Okay, so here's our logic. We have a temporary array list while there are still cards to transfer. I'm going to random an index. I'm going to add that to my temp array, and I'm going to remove it from cards. So cards are coming from cards. They're going into temp, so temp is going to eventually have all 52. However, at this point, once the loop is finished, cards has nothing in it. They're all in temp, right? And if you look, the rest of my program, like the 2-string, the rest of the deck, I should say, it's relying on cards, but I just emptied out cards. So the last thing we want to do is say that cards is now equal to temp. What we're telling it is that this variable is going to stop pointing at the array list it was pointing at because that one's empty. Instead, it's going to point at temp. Temp is a variable, and it was looking at this array list. Temp is a local variable, so it stops existing here. So temp goes away. Cards is the only one that's left. It is an instance variable. It has a bigger scope. As long as the deck object exists, the cards variable exists. So we effectively randomized cards. Let me show you. Right? I'm going to run the program. Note that we are calling the shuffle. Right? The flow of this is we create a new deck. We call the constructor. We go into the constructor. It tells cards to point at an empty array list. We then call the fill method. Go into the fill method. It adds 52 cards in order to our cards array list. We then call shuffle. Shuffle creates temp. We randomly transfer the elements over. We then tell cards to point out what temp was pointing at. Temp goes away. Cards is the only thing that's left. And now it should be in a random order whenever we actually go to print it off. And there it is. One thing I would consider checking is, do we have all 52 cards there? So this is actually an easy check, and so I would put it in the 2-string. Just kind of add to this. You don't have to get fancy with it. I would maybe put a space there, but we would add cards.size. Just a simple number is going to show up at the end of this. What did I do wrong? Oh, this is a single character. Thanks, IntelliJ. And was trying to do a character literal when I needed a string literal, and you do see we have 52. I'm glad that showed up 52, because that would have been pretty embarrassing otherwise. Okay, so that was much easier than trying to random an array. we have our deck. It's got all 52 cards. It's random. This is actually finished for now. Let's turn our attention to the hand class. And we're only going to do a little bit. There's a lot of methods here. Some of them are actually pretty fast. I basically want to get a constructor going. I want to basically do this hit method, which is how we're going to get a card into the hand. And maybe we'll do like a 2-string or something. So I am back in Blackjack. Let's create a new class by right-clicking on SRC, making a new Java class called Hand. Hand, if you recall, has just a no args constructor. So we're going to say public hand. Okay, think about this for a moment. What is a hand? A hand is very similar to a deck in that it, sorry, I'm now just realizing that I missed a method. We forgot to do deal. Let's plug that in. Super important. Let's plug that in. All right. So we created our deck. We filled it. We shuffled it. We need to basically be able to deal. And the idea behind deal is that you're taking a card from the deck and you're going to end up spitting it out. You're going to give it to somebody. If you look at this, right, deal doesn't take in any inputs. It knows what it needs to do. You just pull the top card off. But notice we effectively have an output. That is the card that is getting removed from the deck and presumably going somewhere else. So we're going to do public card deal. So simply put, I want to just get rid of the first card. Right? I want to take, you can basically deal from the top, you can deal from the bottom, and it ultimately doesn't matter because all this stuff is random anyway. What do I mean? I basically want to do card.remove 0. Cards.remove 0. Right? That's going to get rid of the first element. You can think about that as the one off the top of the deck. Okay? What I need is for that to basically get returned. Now, super important with this remove method is that whenever you remove, not only does it remove the element that's there at that index, it also returns it. So what I have highlighted is the element that was removed from index 0. That element is a card. Simply put, I'm going to return it. Not only are we going to remove the card that is at index 0, we are also going to return that card. Right? Notice that IntelliJ is happy. I said I'm going to return a card, and I did. Let's test this out. I'm going to flip over to my driver. Right, so we create our deck. We're going to see our deck. I then want to do sout on deck.deal. Right, so we'll go into our deck object. We'll tell it to deal the top card off. This returns a card, which I'm going to print. In theory, right, our deck got shuffled. So let's see what it looks like initially. Right, we are going to see what it looks like initially. The very first card was an 8 of clubs. If I were to actually print off the deck again, it's going to be slightly different this time because it's random every time we make the deck. Right, the first card was a 6 of spades. You see it right there. It got removed. We don't even see it in our deck anymore. Now the thing is, if we do this, yeah, we can do that. If I do this 52 times, we're going to go through all cards. Right? All my cards are here, and you see that we're left with nothing. Size of our deck is 0. If I go and try to do this 53 times, we got a problem. We go out of bounds. So there's lots of ways that you can handle this, and what I found to be just the sweetest is that whenever we go to deal, let's check. Before I try to remove the element at index 0, let's make sure there's something there. How do I know? How do I know there's at least one card there? If cards.size is greater than 0. Really, what I want to do is if cards.size is equal to 0, that means we've run out of stuff, right? There's no more cards. I told you there were various options. We could abandon the deck. You could basically not actually remove any cards, right? Instead, we basically just advance an index, and then once we get to the end, we shuffle it and then reset our index. So we're not technically removing the cards from the deck. But this is super sleek in that we just do a simple check. If the size of our cards is nothing, we fill it. So what happens is whenever we go to deal the card and there's no cards there, we put 52 cards back in it and then shuffle that. Then we deal the top card. Okay, I'm going to run it again, and keep in mind that we're trying to do 53 iterations. You see the deck initially, we go through all 52 cards. This was actually the last card of the deck. We ran out. When I tried to do this, we saw there are no cards there, so we put 52 new ones in there. We shuffled it. We returned the 5 of hearts, and if you look at this deck, I'm going to scroll all the way to the end, we're left with 51 cards because I just removed the very first card, a 5 of hearts. Okay. I do want to get started on hand a little bit. It's going to be very similar. In the same way that a deck has an array list of cards, a hand is going to have an array list of cards. We can call that cards as well. All right, so I've got my instance variable plugged in. This is mad at me. I skipped the import step. I'm going to hover this at Alt-Enter. And their array list has been imported. I need to initialize this. Cards is going to be a new array list of cards. Okay, I think that's pretty much it for the constructor on hand. I'm going to double check this before I say something crazy like that. Yeah, that's all we're doing. We have a hand, and initially there's nothing in it. And in Blackjack, the action of adding a card to a hand is known as hitting. We see that here on our public interface. Right? So what I want to do is write this method, public void hit. Importantly, hit actually takes in something. Right? We need to find a way to get a card into our hand, which is technically into this card's array list. So we need to take in a card object. This is the card that I want to add. Right. This method, simply put, adds card to this hand, effectively this array list. All we got to do, cards.add this card. This will help us build up a hand. In order to see this, I'm going to create a toString. I'm not alt-inserting this one. This one actually is on my public interface. All right. Eventually, it's going to be kind of customized relative to what we would alt-insert. But for right now, it's going to look very similar. I'm going to return cards. Notice that it's mad at me when I do this. Simply put, I want to return a string, but right now I'm trying to return cards, which is an array list of card. A couple of workarounds. You may have seen this in other videos. We could call the toString of the array list, which will give me a visual representation of what the array list looks like, similar to this. Another kind of hackney way is that you can force a call to the toString by doing concatenation. In this case, with ultimately nothing. Okay, doesn't matter. I just want to test. Let me flip to my driver. I'm going to leave my deck. I'm going to get rid of some of this other stuff. I want to make a hand. Eventually, the hand is actually going to belong to a player, and it's not going to be just floating out here. So I'm going to create a hand. Initially, there's nothing in it, and we'll be able to see that. The way that we'll get cards in it is by pulling them from the deck. Meaning, I can take the hand and tell it to hit. When it hits, it needs a card. The card in this case is going to come from the deck. Right? When I call deck.deal, that returns a card. That is effectively the top card of the deck. I'm then adding it to the hand. It's important to note that when we deal it from the deck, it effectively gets removed. So it's not in the deck anymore. It is in the hand. Okay. Let's see this. I'm going to create the deck. We'll see the deck initially. We'll see that the hand has nothing in it. We'll then tell the hand to hit. And the card should come from the deck. So we'll see what the deck looks like afterwards. And it should go into the hand. Here's our deck initially. Our hand has nothing in it. Here's the deck after the fact. Notice that the 3 of diamonds is no longer there. It is, however, in the hand object. Okay. That's probably going to be a good spot to pause it. We really got deck functioning. We got our hand started. We're going to move in here pretty soon and knock out these methods. It looks like a lot, but a lot of these are actually really short. I'll see you in the next one.